A 2.2-ton van would be placed on 4 small columns made not of concrete or steel, but gravel. Ordinary gravel like this. But how would it hold a vehicle when this same stone could not even support the weight of a man? Was there a polymeric material that could reinforce simple gravel columns so they could support the direct weight of a vehicle? Engineers wanted to prove that such a polymeric material, a ژئوگرید, could successfully stabilize common soils and aggregate like those featured here. True, ژئوگریدs have been utilized in many reinforcement applications, but questions remain as to whether they could withstand such immediate, enormous pressure. Engineers from Norway were fascinated about this idea and offered support to the team at Weimar. Norway provided its high-strength ژئوگرید material. ژئوگریds are made of stretched, monolithic flat bars with welded junctions. It is typically used for reinforcement in steep slopes, landfills, roads, walls, veneer stabilization, hydraulic engineering, and many more applications. But should this experiment be attempted? Just one error in the calculations could fold the support columns and bring the 2.2-ton van crashing down. 4 mold cubes would be filled with gravel of grain sizes 8 mm to 32 mm. 4 ژئوگرید 4040 Q1 ژئوگرید layers would be inserted at regular intervals in the columns. The van would be driven next to the prefabricated formwork cubes, then placed on top by forklift. After lowering the vehicle onto the 40 cm cube-shaped columns, the forms would be removed. The vehicle would rest solely on the ژئوگرید reinforced gravel. Would it really hold? The engineers were certain it would, even with a column surface of just 40 centimeters times 40 centimeters. ژئوگریds are extremely strong and durable. They are manufactured to accept, stress easily, and stabilize soils and aggregates. On the day of the demonstration, the event was opened to the public, and public transportation was arranged. The team wanted doubters and believers alike to witness this. Hundreds of spectators, press, and TV representatives attended. The formworks were filled and the ژئوگرید layers were inserted. The van was positioned and lowered. No error could be made. Everything had to fit exactly. As a safety precaution, the forklift remained in place after the van had been lowered. More than 2.2 tons were now resting on the stone columns. Were the Norway engineers' calculations correct? What would happen when the formworks were removed? Would the ژئوگرید reinforcement hold up to the direct pressure? Slowly and cautiously, the forms were undone. Tension was in the air. The formwork for the first column was beaten aside. The gravel groaned with a subtle shift, and a murmur went through the audience, but the column held. Then, the second column. The ژئوگرید reinforcement held. The third column was freed. Finally, the fourth and last column's form was removed. The vehicle weight was entirely on the reinforced gravel columns. And yes, the ژئوگرید reinforced columns held up against the weight of the van. This is excellent proof. ژئوگریds perform excellently in difficult design situations such as subgrade reinforcement and veneer stabilization. What is true of the performance in this small experiment is also true of large-scale critical application performance. The applications for ژئوگرید geogrids are many. Base course reinforcement for highways and haul roads, reinforced earth noise protection barriers, steep slope stability, and many others. ژئوگرید is not only a strong engineered design choice, it is also an economically and environmental smart choice for clients and contractors. And now you can enjoy the entire set of placing a 2.2-ton van on 4 ژئوگرید reinforcement gravel columns in the fast motion sequences.